Alright, hello and welcome to today's video. I'll call this pulley problem 3. Pulley #3 to mean the third kind of pulley problem that you should be seeing in classical mechanics. So, on Newtonian mechanics, to be more specific. So in today's video, we're just going to look at this pulley. The first we want to identify is our tension forces. So notice that there is a tension force right here. Alright, and on the 5.00 kilogram side, we also have a tension force right here. So notice that because we are neglecting the mass of the pulley, T1 is gonna equal T2. So whatever value we get for T1 is going to equal T2. Now there's going to be the force of gravity or the weight force on the 10 kilogram block. So let's just indicate that. Alright, so we have m2g to be our weight force and T2 to be our tension force. Now we're going to call the 10.0 kilogram block as what? As M2, and the 5.00 kilogram block as M1. So the big question now is, in what direction will this object accelerate? Well, M2 is larger, 10.0 kilograms. If you multiply that by 9.8, you're going to get a force that will cause an acceleration towards this direction. So since we know that the object is going to accelerate towards the 10.0 kilogram block, we'll assume that anything towards any vector towards that direction is going to be positive, and any vector opposite the direction is going to be negative. So therefore, what are we going to do? The M1 block is on an incline, so we have to resolve all the forces acting on an incline. There's going to be a normal force acting upward. As you can see, there's also going to be a weight force acting downward due to the force of gravity. M1G. Notice that the angle theta, which is 40.0 degrees, is the same as this angle right here. So this angle right here is also 40.0 degrees. So now let us resolve the M1G. Now notice that for this part, we're going to have, for the adjacent side, which is adjacent to the angle theta, we're going to have mg cosine m1g cosine theta. And for the opposite side, opposite the angle theta, we're going to have m1g sine theta. So notice that the angle theta, which is 40 degrees, has given us our force parallel to the incline and perpendicular to the incline. So you see that m1g sine theta is going to be the component of the weight force parallel to the incline. So now that we have resolved all the forces acting, so let's start with the y direction. The sum of all the forces acting in the y direction for the M1 block is equal to the normal force, which is in the positive y direction, taken up as positive, minus m1g cosine of theta. Notice that there's no acceleration in the y direction, so what we have is 0 equals the normal force minus m1g cosine of theta. So therefore your normal force is equal to m1g cosine of theta. But this is of little importance to us because there is no acceleration in the y direction for the m1 block, which means that what we need to find is the acceleration in the x direction. Now there is a quicker way that we can solve this. So we are going to skip the tension forces for now. Notice that Newton's law says that the net force, taking it as one system, the net force acting is equal to ma. Now if that is the case, therefore we are going to see that the net force is equal to the total mass, m total a. So now what are the forces acting on this system? Taking it as one whole system, we can see that everything towards the m to g part is what? Is positive. And every vector opposite that is going to be negative. So therefore m to g is going to be positive minus m1g is going to be negative. m1g sine theta is going to be negative. So therefore, because it is the component of the weight force, the m1 weight force parallel to the incline, it is what we're going to consider in this situation. So that's going to be minus m1g sine theta, and that's going to equal what? M total A. Now this simply means that A acceleration is going to equal what? It is going to equal m2g minus m1g sine theta, all divided by m1 plus m2. So that's the formula for your acceleration. Now, how do we find the tension forces? Notice tension is a force. So how do we find the tension forces? And notice that T1 equals T2 because you are neglecting the mass of the pulley. It doesn't have an inertial mass, so we're going to neglect the inertial mass of the pulley. So notice here that for the M2 part, let's take the M2G and the T2 part. M2G is going to be positive because the acceleration is towards that direction, and the acceleration vector is similar to the M2G vector. You can see that they are both pointing downwards. So this means that M2G is going to be positive. So what we're going to have is that M2G T2 is going to be what? T2 is going to be negative. So we're going to have minus T2, and according to Newton's second law, the net force acting on a system that is on this block must equal ma. So therefore, once we find our acceleration, we can simply say that what? T2 is equal to what? M2G minus M2A. So T2 is going to equal M2G minus A. So there you have it. That's how you find the acceleration and the tension. Notice that T2 is equal to T1. If you don't want to find for T2, you can also find for T1 in a similar way. So thank you for watching.